Forglass has long been on a mission to decarbonize glass production. We believe that significant improvements in both energy costs and emissions of CO2 can be made, and we have the formula that's unlike any other. In fossil-operated furnaces, heating the components of the batch consumes as much as 80% of the energy, so it ought to be delivered as efficiently as possible, first and foremost. In a typical furnace, the return convection current from the hot spot towards the batch charger is the main energy bearer to the batch blanket. This is also true in furnaces equipped with standard boosting electrodes, which don't generate strong vertical convection currents and so do not provide adequate mixing of the hot glass with cold batch, regardless of the amount of power delivered. To supplement the current technology with a new tool to enable efficient heating of the batch, we give you the Forglass Mixing Electrode, a device that combines the functions of a boosting electrode and a bubbler. Special channels inside the electrode allow argon or nitrogen bubbles to carry hot glass to the surface, accelerating the melting process. Forglass mixing electrodes are the best and today perhaps the only available devices that deliver energy to the cold batch by the shortest path and directly from the most efficient source. The gas passes through the working electrode, achieving very high temperature and eliminating energy losses. Accelerating the sand dissolution rate by as much as 25% means that the same furnace can now produce more glass with lower specific energy consumption and lower emissions. The Forglass mixing electrodes are able to distribute more electric power in glass than previously tested in working furnaces, while the synergistic effect of the joule combined with the kinetic energy of gas bubbles impacts the same area of molten glass and batch blanket. The result is much more efficient heating of the batch. Barrier boosting with Forglass mixing electrodes is very effective in dissolving sand grain relicts and releasing gases at the surface 50% faster than with standard electrodes. Forglass mixing electrodes work equally well in furnaces with low power boosting and in hybrid furnaces where the share of electricity can be as much as 50–60% or even higher. They provide effective control of the melting stages and flexibility in using two sources of energy. The increase in the melting rate can be used in several ways, reducing the specific energy consumption, reducing the boosting power, or increasing production. The proprietary Forglass mixing electrode. Join us in breaking the barriers of current technologies.